So here's a question from the JEE 2020 Paper 1 Physics. And the question says, an open-ended U-tube of uniform cross-sectional area contains water, which is obviously of density 1000 kilogram per meter cubed. Initially, the water level stands at 0.29 meters from bottom in each arm. So initially, this situation might have looked something like this. And the water level was same, so was at its with the same height, which is 0.29 meters. Kerosene oil, a water immiscible liquid of density 800 kilogram per meter cubed, is added to the left arm until its length is 0.1 meters, as shown in the figure. The ratio H1 upon H2 of the heights of the liquid in the two arms is. So let's think for some time. Well, if you mark this area, the horizontal section, let's say it has some length x. So if the cross-sectional area of this tube is A, this horizontal portion holds AX volume of water, and same in this case as well. And the reason why we are doing this is because we need to find the ratio between H1 and H2, and the best way to do that will be form some sort of equations. The best will be to form two equations containing H1 and H2 and solve for them and find the ratio. So let's try that. However, if you just look at just the water part in the final situation, water here has, in the left arm, has a height of h minus 0.1 meters, and here it has h2. So definitely h minus 0.1 meters plus h2 is equal to height of all the water that was stored in here, which is 0.58 meters. So we now know that h1 plus h2 is equal to 0.68 meters. That's the first equation. What about the second one? Since we have been given the densities of these liquids, it might be a good idea to play around with what the pressure might be at the bottom. So let's say that this point is point A, this is point B, and this is point C. Now, since these 3 points are on the same horizontal level, we can say that the pressure at A is equal to the pressure at B, and that is equal to the pressure at C. Now, if you try and write an expression for the pressure of A in terms of the atmospheric pressure, let's say the atmospheric pressure is P naught. If you want to write an expression for these and then solve them, that might give us a new equation. So first, for the left arm, here the pressure is P naught initially, and then you descend down the height. So here the pressure will be P naught plus rho of this liquid. The density of this liquid is 800 kilogram per meter cubed times G times 0.1 meters. And so and then again you descend some height. So let me just write that here. We're writing PC. PC is equal to P naught plus 800 kilogram per meter cubed times G times 0.1 meters, plus again you descend in, but this time in different liquid, and this liquid has a height of h1 minus 0.1 meters, so this will be plus 1000 kilogram per meter cubed times g, acceleration due to gravity, times h minus 0.1 meters. If you try and write the pressure at B, well, that's even simpler. It's simply P naught plus, you just descend this height h2, so it will be 1000 kilogram per meter cubed times G times h2. Now, since both of these are equal, you might as well just write this equal to sign, cancel these P naughts, cancel these G's, all of that is pretty easy. And once that is done, you can also cancel these kilogram per meter cubed units as well if you want to. And now you have 80 meters. I'm multiplying this out. So 80 meters plus 1,000 h minus 100 meters. Don't confuse this m with a variable. Only h. The h's are a variable. This should be h1, by the way. And here you have h1 again. This is equal to 1,000 h2. And with this you can write that, we can easily write that h1 minus h2 is equal to 20 meters divided by 1,000, and that is equal to 0.02 meters. Now this is pretty easy, you just need to solve both of these equations. So solving them, that will give you h1 is equal to 0.68 plus 0.02 meters divided by 2, and h2 is equal to 0.68 meters minus 0.02 meters divided by 2. This is equal to 0.35 meters. This is equal to 0.33 meters. And we were asked to find out h1 over h2, which definitely is just 35 upon 33.